Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Josh Vickers, and I will be your technical host and moderator for today's event. Today's webinar is entitled Isotopes, Aiding Identification of Undocumented Border Crosser Human Remains. Our subject matter expert for today is Ms. Saskia Amar. She is an anthropology PhD candidate at the University of Coimbra in Portugal. She focuses on forensic anthropology and the use of isotopes to predict resident patterns and human diet using chemical signatures in human remains. For this project, she traveled from Cancun to Tijuana to collect reference samples that represent the isotopic environment of Mexico. Furthermore, she spent 3 months at the Pima County Office of the Medical Examiner collecting samples from the unidentified individuals and volunteering for the Colibri Center for Human Rights. Currently, she is at the Vrije University in Amsterdam and is working on the analysis of the collected samples. A quick disclaimer, the opinions, findings, and conclusions or recommendations expressed in this presentation are those of the presenter and do not necessarily reflect those of the Department of Justice. Any products and manufacturers discussed are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice. And now, without any further ado, I would like to go over and switch everyone's layout and hand the microphone over to our presenter today, Ms. Saskia Amar.
Hi, everybody. Thank you very much for that introduction and having me here today. As Josh already said, today I will try to introduce you to the world of isotopes and present to you how spatially distributed isotope data sets can be used to address the humanitarian crisis at the border from Mexico into the United States. The approach that is being used in this project combines techniques from chemistry, geology, as well as forensic anthropology. All right, so let me get my acknowledgement out first while everybody's still paying attention. First of all, I would like to thank the Forensic Technology Center of Excellence and the National Institute of Justice for setting up this webinar. I've listened to quite a few of the webinars myself and always found them very interesting. Then I would obviously like to thank the American Academy of Forensic Sciences, Humanitarian and Human Rights Resource Center for the grant that is obviously making this project possible. The grant is in part sponsored by the AAFS as well as the NIJ. Thank you to my university, the University of Coimbra in Portugal, and my supervisor, Professor Cunha, the Vrije Universiteit in Amsterdam, where I'm currently analyzing my samples, and the University of Utah, where parts of the water samples were analyzed. Thank you to Professor Bartelink and Dr. Lehn, who have helped me tremendously throughout this project. Last but not least, I want to acknowledge the Pima County Office of the Medical Examiner in Tucson, Arizona, that provided me with samples from some of their unidentified remains that I'm using to match to my model. Also, thank you, Dr. Anderson and Dr. Wallner, for being the greatest mentors. All right, so to our little game plan for the next hour or so. First, I'll give you an overview over the humanitarian issue that we are dealing with here. Then I'll try to introduce you to the world of isotopes, as I said. Following that, I'll present to you my PhD project, which actually combines the humanitarian issue with the isotopes. And lastly, I'll talk a bit about how isotopes could potentially be of use to you. All right, so I'm not sure how familiar everybody is with forensic anthropology, so let me first say a couple of words about what we do. Generally speaking, forensic anthropology is the examination of human skeletal remains for law enforcement agencies to determine the identity of unidentified human remains, interpret trauma, and estimate time since death. Forensic anthropologists are also often called upon to help with the recovery of human remains. The establishment of biological profiles, meaning estimating sex, age, ancestry, and stature, is usually the main aspect of our work. Unfortunately, this is oftentimes not enough to actually identify the person in question. And much of the difficulty associated with identifying decedents, and especially undocumented border crossers, stems from the inability to narrow down the search area to more probable options. And this is where my project will come in handy. It is a human right to be treated with dignity even after death, and every human has the right to identity even after death. And since 1998 actually, more than 7,000 people have lost their lives while trying to cross the border from Mexico into the United States. In this map, you can see all the recorded deaths of undocumented border crossers in the state of Arizona alone. And I mean, this picture in itself is quite impressive, I think. And but as you can imagine, this number is a gross underestimation of the people that have actually died so far, because obviously the number only represents the people that have actually been found. And considering the geography along the border and the fact that a lot of the land along the border is privately owned, especially in Texas, the number must be significantly higher. So now to actually understand the complexity of this issue, it is important to talk a bit about why the border has become so dangerous and deadly. The deaths and disappearances of thousands of migrants are being seen as a direct result of various factors. The North American Free Trade Agreement has had a controversial effect on Mexico, really. Back then already, when it was established, undocumented migration was already a main concern, and the idea was to create enough jobs within Mexico that Mexicans will decide to stay in their country. But unfortunately, it has actually caused the loss of jobs, especially in rural areas. And furthermore, the enforcement was centralized to larger communities and cities, which created a funnel effect. So people used to cross into safe territory, such as San Diego or El Paso, but the border crossing movement was now funneled into more remote and uninhabited terrain, like the desert, really. And this is a policy known as prevention through deterrence. The initial thought was that people would see how incredibly harsh the desert is and would not risk the journey. But unfortunately, history has just proven this assumption to be incorrect. And due to the economic implications, people believe that they had and still have no other choice than to cross. And due to the increased enforcement and militarization in the urban ports of entry, the number of migrant deaths in Arizona alone has risen from an average of 12 per year 20 years ago, not quite, up to 170 in the more recent years. As one can see, this funnel effect that was created has resulted in a tremendous increase in the number of individuals who have died along the border. So there's a couple of organizations, institutions, and groups that aim to help identify undocumented border crossers. Many of them operate mainly based on volunteer work and donations. Some of them I'm mentioning and showing here, but there are more out there. So first of all, Operation Identification. It is an effort by Texas State University and sits on the shoulders of professors, primarily Professor Bradley, and students who volunteer their time to this humanitarian issue. A main issue in Texas is the medical examiner office, or lack thereof, really. Since there are so many counties in the state, they have so-called justice of the peace system in some places. And these are elected officials who decide whether or not a person will receive an autopsy. And as you can imagine, unfortunately, many of these elected officials lack the knowledge and or compassion maybe, and decide that presumptive migrants should not receive an autopsy. These unautopsied individuals were then buried in oftentimes unmarked individual or mass graves outside of the town, or sometimes even within the cemetery limits. Not only is the basic biological information lacking, even when the person was in very early decompositional stages, when he or she was found, almost always there's no information about where exactly and how many individuals were buried. So now, for the last couple of years, professors and students from Texas State University and other universities have traveled southwards to excavate these graves. And now these individuals that are being recovered are brought back to the university where they will receive a proper examination. The individuals that were sampled for this project came from the Pima County Office of the Medical Examiner. The PCOME is really the poster child of how the identification efforts of undocumented migrants can be handled. At Pima County, forensic anthropology is an well-established and respected. The medical examiners and the forensic anthropologists truly work as a team and enjoy each other's expertise. The PCOME has also worked closely with NGOs, the consulates of Mexico and other Central American countries, as well as Border Patrol. These relationships are essential to be able to identify as many migrants as possible. And the way the PCOME is organized has really proven them right, because their identification rate is at about 70%. And as you can imagine, that is incredible considering the context. Lastly, the NGO Colibri, they operate out of Tucson, Arizona, and they collect missing persons reports and try to match the data to the decedents. They serve as a link between the medical examiner offices and the families of the missing. So now we're going to switch gears a bit and go to our beloved isotopes. There are 90 known chemical elements, which consist of atoms, protons, neutrons, and electrons. Together, these are referred to as subatomic particles. An atom consists of two parts, the nucleus and the orbitals. The number of protons and electrons are always equal in an atom of any element, but the number of neutrons may vary. And about 2/3 of the 90 chemical elements occur in more than one form, and these are called isotopes. Isotopes of an element contain the same number of protons, but differ in their number of neutrons, which means that isotopes differ in their atomic mass. For example, carbon has 15 known isotopes. Isotopes are generally divided into two key groups, the stable and the unstable ones. Two of the examples you can see up here. While stable isotopes retain their nuclear configuration, unstable isotopes decay, change their nuclear configuration over time. All right, so stable isotopes are found in all organic elements, which are the basic building blocks of our lives. Therefore, all plants, animals, and humans naturally consist of isotopes. Due to biological, geological, and environmental processes, isotopic composition of ecosystems varies from place to place, and scientists who use isotopes oftentimes make use of these regional variations. Both unstable and stable isotopes have been used in various fields of research, such as archaeology or paleoclimate. And I guess C14 radiocarbon dating is probably the most commonly known use of isotopes. In order to better capture the minor difference in isotopic abundance ratios, they are expressed as delta values against an international defined standard. The values of a sample can be positive or negative against that standard. The element in the sample can consequently be isotopically enriched or depleted. Specifically, positive values simply indicate that a sample has more of the heavy isotope than the standard it is compared to. For the geo and trace elements of strontium and lead, raw ratios are used because they are meaningful to several decimal places. Values from all sample types are being made comparable across laboratories around the world by using the per mil symbol. This is not really a necessary step, but rather a matter of convenience, as it is extremely small numbers that we are dealing with, and they're simply easier to communicate. So isotopes can be used in a lot of different ways, but primarily stable isotope analysis is a very effective geolocation tool. Isotope analysis is a perfect record of movement and eating habits of an individual throughout life, especially because isotope signatures are usually not altered once they're deposited and can be examined at any point during life or after death, depending on the research question and body tissue that is being used. Here are some exceptions. When, for example, a body is buried for a long time, it is possible that water deposits and may vary those values. So it may be necessary to take soil samples, etc., in order to determine if there is any influence. Since the isotopic analysis does not rely on the memory of the study subjects, it is very applicable, for example, also to living people and not just for forensics. It does not require any special skills of the participant nor the collecting researcher, and that is really a great asset. All right, so why do we even use stable isotopes here? There are many reasons why traditional identification methods fail when working with undocumented border crossers. One of the main reasons is that there's simply no coherent database of the missing persons and the found individuals. While many institutions work hard to merge all the information, some families may simply not report their loved ones missing. The reasons for that are numerous. Sorry, I'm going to have to take a sip. Also, even if there are distinct features that may be able to identify a person, there may not be a reference to compare it to. So, for example, many migrants may have never had an X-ray done, but do have dental work. Fingerprints can oftentimes not be recovered due to the advanced decompositional stages that are seen in border crossers. And again, we would obviously need a reference, which is oftentimes just not available. DNA typing and comparison is often not possible for various reasons. Investigators do not collect DNA samples in all cases, for example, because the method is too expensive or because the person is found is merely presumed a migrant and therefore not a priority. This is the situation which I was referring to in Texas earlier. DNA genetic databases also present a significant issue here. If DNA is collected, it is most of the time submitted into CODIS, the genetic database run by the FBI. The main problem with this database is that CODIS lacks most family reference samples of missing migrants. It mainly includes the DNAs of arrestees and offenders, which is most of the time of no use when identifying migrants. Furthermore, many persons are too concerned with their privacy to submit DNA samples into the database, or are not even allowed under U.S. law. Furthermore, CODIS is usually not cross-referenced internationally, which means that DNA submitted by families in other countries will, under normal circumstances, not be cross-referenced with the U.S. database. And therefore, non-governmental and human rights groups are an essential part in the effort of identifying the remains of presumed migrants, since they're able to work with the families of the missings without the involvement of the government. Again, for all these identification methods, there has to be a person actually reported missing, a probable option for a reference, and lastly, the reference actually available. As mentioned before, much of the difficulty in identification and the return of the decedents to their families results from the inability to restrict the search area to more probable options. By doing isotope analysis, we do not really find the needle in the haystack, so we don't identify the person, but we will reduce the haystack to a hopefully more manageable size. With that information, local missing persons reports will be possible to be searched, and hopefully it will then be possible to align the data gathered from the biological profile and the isotope analysis with more precise options. You have probably gathered by now that isotope analysis will never be a primary identification tool. What we really do is test hypotheses with isotopes. So, for example, we can find out about the individual's dietary preferences, their travel history, and their birthplace. However, it is not possible to say that the person is, let's say, from Atlanta. Unfortunately, isotopes have a lower resolution than that. All right, so let's switch gears a little bit here. I said earlier that scientists make use of the regional variations when working with isotopes. And a good way to depict those variations is through an isoscape. An isoscape or isotopic landscape looks pretty similar to a heat map and represents different isotopic values with different colors. The example here is a tap water oxygen isoscape that I created recently, and you can see the corresponding values on the right. The circles are the samples. Let me see if I can point them out here. There we go. So those are the places where the samples were taken, and the squares reflect the sample locations that is being interpolated. The isoscapes are produced by executing process-level models of elemental isotope fractions or distributions in a geographic information system, GIS really. This map is an excellent tool to create conditional correlations, which will come up a bit later again in this presentation. So now to the elements that I am using. Oh, I still got my little point on. To the elements that I'm using in the study. And that will be oxygen, hydrogen, nitrogen, carbon, sulfur, strontium, and lead. Each one of these has a different purpose and reason to be used. I'm going to go briefly through those now. So first, oxygen, hydrogen. Hydrogen and oxygen inform about the climate and the distance to the sea through precipitation patterns, which can be seen an example of here in this picture. Lighter isotopes are retained in the atmosphere longer, which means the rain close to the ocean contains heavier isotopes, while the rain further away from the ocean consists of lighter isotopes. You can see that here in the picture pretty well as well. This is also where I want to point out waterisotopes.org. It is a huge database consisting of water data from all over the world. It does not only contain precipitation data, but also tap water, groundwater, and all sorts of other waters from all over the world. Anybody can add their data sets, and they even have an interactive tool allowing on-demand estimation of the stable water isotope ratios of precipitation at any site in the world. The carbon isotope values are informative about the nutritional basis of an individual. Plants use two photosynthetic pathways whose plants are divided into C3 and C4 plants. C3 plants include fruits, vegetables, and some grains such as wheat and rice. Individuals who eat predominantly C3 plants will present low carbon-13 values when analyzed isotopically. C4 plants are plants such as maize and sugarcane and are usually higher isotopically. Nitrogen, on the other hand, informs about the diet as well. In particular, the consumption of meat and dairy products, or lactose off really. Nitrogen also tells which kind of fertilizer is used, so if the product is organic or not. Together, nitrogen and carbon are informative whether a person was vegan, vegetarian, omnivore, even carnivore, and what kind of food the animal was fed, really. So as you can probably imagine, these isotopes can be very telling about the dietary preferences and are therefore very representative of the cultural and regional preferences that the persons have. For example, it will be relatively easy to distinguish between a person from Japan or China and someone from, let's say, Mexico. Asian countries eat a lot of rice, a C3 plant, while Mexicans eat a lot of corn, a C4 plant. This will ultimately be visible in their isotopic composition. Bartelink et al. Has actually shown how useful isotopic variations can be when trying to repatriate war casualties. The DPAA is working tirelessly on identifying remains from wars, such as the Vietnam War or the Korean War. And as you can imagine, it is oftentimes impossible to tell from the skeletal remains where someone may have originally come from. Here we can see the isotopic differences found in U.S. Americans and Southeast Asians. This is obviously an excellent tool to differentiate between U.S. and foreign soldiers and makes the identification process much easier. It also means that remains that do not belong to U.S. personnel can be repatriated to their home countries. Isotopic sulfur values answer questions regarding the consumption of seafood, proximity to seawater, as well as geology. Sulfur isotope ratios reflect both diet and geographic place of residence, because sulfur values in plants vary with the isotopic values of the underlying bedrock. Higher sulfur values are representative of marine water, intermediate of terrestrial water, and low are found in freshwater. Strontium varies predictably between different geological areas based on their age and composition, and through weathering, it is transferred into the hydrosphere and ecosphere. So animals take up strontium from the environment and diet and incorporate into these ratios into their skeletal and organic tissues. Strontium is a decay product of rubidium. However, it is not radioactive. Lower strontium values are associated with the younger rocks. So for example, if you have a strictly vegan person, the strontium values are an average of the plant material that they ingest. All right, so a small amount of the lead variations occur in nature and are dependent on the local geology, similar to strontium really. The isotopic values of lead are representative of the national signature through anthropogenetic and influences from the industry, transport, waste, incineration, and heating. Plainly said, lead isotope ratios are really descriptive of sources of lead contamination. So, which skeletal elements, which tissues can be used for isotope analysis in humans? Here I'm going to show bones, teeth, and hair. And the different tissues reflect different snapshots of time. For bones, isotopic values are an average of the remodeling rates. So for example, a rib has an approximate turnover rate of about 5 to 8 years, while the femur captures about 20 years of isotopic values. As I said, this is really dependent on the remodeling rates of the skeletal element and has to do with the bone density and type of bone. For the teeth, it is an entirely different story, really. Teeth form in utero and during the early years in life. When what part of the tooth develops can be seen in this little tooth atlas here. So by choosing a certain tooth, we choose a certain time period in the individual life. So we can say exactly we want to examine the time around birth, so we choose the tooth accordingly. Once the tooth is formed, there won't be any alterations in the tooth enamel, and the isotopic values will not change. So that is definitely a huge advantage. Then the last tissue that I'm using is hair. Hair grows at about 1 centimeter per month, and the time period that is being analyzed, therefore, is obviously very dependent on the length of the hair. So if you take a man who has 1 centimeter long hair and we make him bald, we'll be able to analyze approximately the last month of his life. But if a woman has half a meter of hair on her head, and we can analyze over 4 years of her life. Obviously, not every single hair on your head grows at the same time, so there is some error involved in that needs to be considered. There's also a lot of, or it is up and coming really, people use nails for isotopic research. The growth rate here is at about 2 to 3 millimeters per month. So now to my project. We have a good background now, and hear more about the project itself. As I said, I'm combining forensic anthropology with cutting-edge techniques in chemistry and geology and forensic anthropology to aid in solving these cases. I'm currently creating various geochemical reference maps called isotopes. You saw those earlier. Specifically, I collected tap water samples as well as modern human hair samples from locals, and these are serving as a reference data of some sort. Once these isotopes are established, to determine isotopic composition of the decedents in bone, hair, and teeth will be used to predict the region of origin as well as potential movement throughout the lives of the individuals. Unfortunately, there's very little research done on isotopes in Mexico, which is why this project has become rather ginormous on me. And the main goal of this research project is to develop a coherent method and a new framework, really, for identifying undocumented migrants through isotope analysis and returning the remains to their families. It is expected that the isotopic analysis of the local hair and water samples will provide complete isotopes of Mexico. which will then be essential to the identification of deceased undocumented migrants through the isotopic and forensic anthropological analysis of different body tissues. The aim is to facilitate and accelerate the identification of the deceased, which will have a tremendous impact on their families and also help solve a human rights issue. You have heard now that the focus of this project is Mexico. Of course, as we all know, not all migrants are from Mexico, but also from many other countries of Central and South America. But history has shown that most individuals found in Arizona are of Mexican origin. That's why I'm focusing on Mexico for now. And also, the project would have otherwise been even bigger, and I would probably never get done with my PhD. Hopefully, it will be possible at some point to continue and expand this research in the future to cover more and more ground and receive an even more precise predictions for these migrants. Now to the hopes and dreams of this project. The results will also lead to the establishment of an analytical method that can be applied internationally. Well, at least I hope so. Not only will scientists from all over the world benefit from this cutting-edge research, but institutions that work on identifying people with different purposes will find it useful as well. Once this scientific template is developed, the method can be applied to other mass disasters, such as the current crisis in the Mediterranean Sea, in which thousands of refugees have lost their lives and await identification. Obviously, this project is not only scientific in nature, but also humanitarian. I see it as our duty to identify these deceased refugees and return their remains to their family. So, what has happened thus far? I collected my samples. I'm currently analyzing these samples, and I have created my first isotopes. In this picture, you can see me take the samples at the Pima County Office of the Medical Examiner. So this is a map of all the collection sites. The red markers show the sites where hair and water samples were collected, and the blue markers in between show the sites where only water samples were collected. You may wonder how these samples were collected. Well, I literally went zigzag through the country for 6 weeks and went to the bathroom at least 3 times in every town to get my water samples. For the hair samples, I went into a barbershop, put on my nicest smile, explained that I was studying hair, got very strange looks for obvious reasons, and in the end walked out with 3 envelopes full of hair from the floor of the barbershops. During the journey, I got significant help from the German soccer team. As some of you may know, Germany really embarrassed itself against Mexico and really during the entire tournament. But people felt really bad for me, which led to very simple sample collection. They pretty much asked me, so where are you from? Germany? Oh, I'm sorry. And we're then pretty much like, here you go, samples. So that was definitely an advantage. The isotopic analysis of the local hair samples and the water will provide, hopefully, a more or less complete isoscape of Mexico, which will then be essential to the identification of the deceased undocumented migrants through the analysis of the different body tissues. So I don't want to bore you too much with laboratory work, but as I mentioned before, I'm currently analyzing my samples at the Vrije Universiteit in Amsterdam, in the Netherlands. We work predominantly in a clean lab to avoid contamination. And I'm not going to go into too much detail, but I do want to know, who do you think is me? Take a wild guess. So I actually do want to show you parts of the lab work. As you have gathered by now, I'm working with a lot of hair, and here is a serious pain. If you don't watch out, it gets incredibly static. So if you don't have patience, this will teach you a serious lesson. As you can see in the video, it is incredibly static. I'm touching it, not even the beaker, but it's just moving around because it's so static. And if I would have opened the beaker without using an anti-static gun, the clean lab would have probably not been a clean lab anymore, and the lab manager would have probably thrown me out by now. And in this picture to the left here, you can see how incredibly static hair gets. A colleague of mine walked in. I rubbed the sleeves of my lab coats by accident, and here we go, hair on end. So if you don't have patience, don't work with hair. If you do work with it, it will teach you a lesson. All right, so as I showed you already, this is an example of an isoscape. I mentioned earlier that I collected tap waters from all over Mexico, and here you can see the end result for the oxygen data. The circles are, again, the collection sites. Since it is impossible to get data everywhere, it was interpolated. The statistical model analyzed the given data and then used it to fill in the remaining areas. So the Guadalajara area here is very notable, obviously. So Guadalajara's main water source is a lake, Lake Chapala, Mexico's largest freshwater lake. And lakes are generally very sensitive to precipitation, and that really explains the deviations from the values surrounding the area. I collected my water samples in June and July, so this is actually the time of the highest precipitation in Mexico. And we can furthermore see here already that there are obvious limitations to the resolution of isoscapes. If we look at the Yucatan Peninsula here, we can see that there is little isotopic variation, even though 18 samples were taken throughout 6 towns. Obviously, more data collection would always be better, and maybe we would see some more differentiation here, but for now we don't. And then I created, let me get that finger out of here. I created conditional correlation maps for the deceased undocumented migrants that are currently housed at the PCOME. This means that I had to convert the oxygen values here for teeth and convert it to water data. And this way I'm able to display it on my previously developed isoscape that we saw just a second ago. I then employed conditional correlations, meaning I told the raster calculator that it should search for areas that have this specific value that I calculated, plus minus 0.5 per mil. This is the usual error that is currently being used. And after making the isoscape that is basis of the statistics invisible, this is what we end up with. So this is a conditional correlation map. And the following individual here was found in Arizona on the Tohono O'odham Nation. And 2 samples was extracted after conventional identification methods did not succeed initially. And using the oxygen isoscape, conditional correlation was established again in order to examine the possible regions of origin for this individual. This was again done by converting the oxygen data obtained from the tooth appetite to tap water gathered during the course of this research. The Resulting conditional correlation can be seen here again. And quite recently, this individual was actually identified, which is obviously great. But even for me personally, even greater is that the reported birthplace for this individual falls right into the predicted area here in Guerrero. Here we go. So this was quite exciting for me. So now if we have data from various elements in isoscapes, we can overlay one with another and narrow down the region of origin more and more. This is then called a multi-isotope approach and will be pretty much the end result of my research, hopefully. So I will be able to create multi-isotope isoscapes for the unidentified individuals that I have sampled at the PCOME. Here you can see an example of such multi-isotope isoscape created by Laffoon et al. For the Caribbean. All right, so now to the exciting part for you guys. You have now heard plenty about isotopes and how they are applicable to undocumented water crosser. Now, I obviously know that not all of you work on this issue and are probably wondering, what are isotopes going to do for me now? So this is why I'm going to present to you a couple of applications that may be relevant to you. This first example is something that actually affects all of our daily lives. Obviously, the prices of food are oftentimes determined by its origin and its quality. So it is, for example, possible to determine if the product is truly organic or if maybe food fraud has been committed. As you can see, the phrase, "You are what you eat," also applies to your cucumber and steak. The same actually applies to the origin of food. So big distributors and grocery store chains oftentimes send samples to isotopes labs in order to verify the origin of the product. So for example, it is possible to test whether champagne is actually from the Champagne. And obviously, you pay mostly for the name here. And it makes a difference. So this is probably one of the most obvious applications. This is a case that was worked on by various agencies and not only displays the usefulness of isotopes, but also the usefulness of international collaboration. So in April 1993, a strangled and badly decomposed woman was found in Austria. It was estimated that she had died approximately 5 months prior, and that she may have originated from Eastern Europe, as her dentures did not match the quality from Western Europe. Here it is also kind of important to note that she was found relatively close to the Hungarian border. And at that time, the borders to Eastern Europe, or to Western Europe rather, became more and more open during that time. This meant that many Eastern Europeans came to Western Europe for work. So over 2 decades later, the Austrian cold case team decided to take on this case again and sent bone sample to Christine Lehn at the Munich Medical Examiner's Office in Germany in hopes to narrow down the woman's region of origin. And this case is actually a perfect example of how good isotopic reference data can give great results. Since the Munich Medical Examiner's Office does not have the machines to run the isotope analyses, the sample was sent to the Freie Universität in Amsterdam, where I'm currently at. And interestingly, the results showed that the deceased woman must have spent a lot of time on one of the Greater Antilles Islands in the Caribbean. And this very exact prediction was only possible because the Freie Universität is currently conducting a lot of isotope research there. And if you remember the multi-isotope isoscape that I showed you just a few minutes ago, that was actually the data that was used for this prediction. So that is quite cool that all worked out. So the detectives now went back with this new information and found out that a lot of dancers from the Caribbean were hired in Austria at that time. So they asked the former brothel owner if they remembered any girl that went missing during the 90s. And one of them actually remembered deregistering one of his girls at the local register office because he had simply thought that she had left without telling him. Apparently that was not completely unusual. And through some more investigative work, they found out the woman's sister in the Dominican Republic and positively identified the lady through DNA analysis. So while unfortunately the murderer of this woman is still on the loose, I think it is still incredible that this case was at least partially solved with the aid of isotope analysis, even though this case is actually older than I am. All right, so furthermore, it is possible to detect periods of starvation through stable isotope analysis, which I think is quite unique, really. So this could, for example, have an application to criminal cases where there is suspicion of starvation. And what is particularly interesting here is that this actually works on human remains, but also on the living. So both of those applications can be very useful, obviously. Then moving on, researchers have shown that it is actually possible to track the place of production of heroin and cocaine using isotopes. And the determination of region of origin also can be applied to explosive ingredients, counterfeit currency, building materials, textiles, and pretty much anything else that you can think of. And I mean, the applications of this research and its benefits are, I think, quite obvious, really. So apparently, I didn't know that there is a huge market for counterfeit tobacco products. And according to these authors, several studies have shown that the concentrations of many trace metals are higher in counterfeit cigarettes than in genuine brands. This obviously leads to an even greater health hazard than smoking genuine cigarettes. So the study showed that it is possible to distinguish isotopically between these products, as well as potentially determine the region of origin. Again, the region of origin prediction is only going to be as good as the available reference data. So the last case, but also a very interesting one. You can not only trace the origin of things, but obviously, as you heard earlier already, you can also determine the age of a certain object or individual. You've probably heard of all the illegal ivory being seized in recent years. And authorities in Kenya were interested in whether the ivory seized was from recent killings or if the rumors were true that corrupt officials were selling the ivory. So the method employed here to determine the time of death of these elephants is called radiocarbon dating. You've probably heard of it before. And what you can see up here is the so-called bomb pools. The C14 increased dramatically with all the nuclear testing after World War II and into the 60s. And This curve now enables experts to calculate when a person or an animal or even a tree dies. In this case, it was the elephants. And researchers found that the killings were recent, which is obviously bad news, but that, on the other hand, the rumors of corrupt officials selling ivory do not seem to be true. So, let me summarize. This project is aiming to facilitate and accelerate the identification of decedents, which obviously has a tremendous impact on their families and tries to help resolve a human rights issue. The results will also lead to the establishment, hopefully, of an analytical method that can be applied internationally. Once the scientific template is developed, the method can be applied to other mass disasters, such as the current crisis in the Mediterranean Sea, in Sudan or Myanmar, where thousands of refugees have lost their lives and are awaiting identification. I'm hoping that not only scientists will benefit from this new research, but also the families of the missing and their communities. I also hope that this presentation has shown you how important this interdisciplinary work is, not just for the identification of undocumented border crosses, but also many other issues. Lastly, I do hope I was able to show you how cool isotopes are, and that you will go out in the world now and spread the word about it. And last but not least, I'm going to present a poster at the AFS conference, so feel free to stop by if you have any questions, would like to know more about my project, or just want to chat for a bit. All right, thank you very much for listening to me and sharing your time with me.
All right, thank you so much, Saskia. A ton of questions that have come in, actually. So we'll go ahead and jump in. In your earlier slides, Amanda asked if the count that you were showing on the map was adults and children, or one or the other, or were they both?
It was all remains found. Women, men, all ages.
Next question was asking.
It's actually available through. Oh, sorry, my bad. It's I think I put the link underneath with the reference, so you can actually go ahead and search it for yourself. So you can choose whether you want to see all the females, all the males, a certain age range, and a certain sector even.
Okay, and that's great that you mentioned that. In the closing, we will have a PDF version of today's presentation available for you to download. So you will be able to download that before you leave today. You can also see Saskia's email address there. So be sure you take that down so you can email her directly if you have any follow-up questions. The next question we have was asking if there was a way to do isotope testing on living people.
Yes, I mean, for example, on hair and fingernails, for example. So obviously, I mean, theoretically, if someone gets a tooth pulled, you can examine that one too. But otherwise, it's probably not quite as feasible as to take a sample of bone from a living person. But yes,
all right.
You can.
Next question, we can kind of put it into two different parts. Asking, is your method that you've been using feasible for familial DNA, or was it geared solely towards criminal investigations? And also, do you have any systems in place where you're joining up with places like 23andMe, Family Tree, or any other genealogical avenues?
No, it doesn't use any of that. So we don't use DNA at all in that regard. So it's really just the chemical composition of the bones, of the teeth, of the element that we're using.
All right. Next question is from Leslie. She's asking, is the Mexico ice escape published anywhere?
And not quite yet. I really just recently developed it. I'm going to present it at the AFS conference. I'll then go over it with some more experts to advise me on what may or may not be able to be improved, and then get it out there. But the oxygen and hydrogen data from the tap water should be available soonish on waterisotopes.org. So it is on there already, but it's still set on private because I haven't presented it.
Next question is asking, how long into the past is an oxygen isoscape relevant for? Is it only useful for, say, 1950 to present, or does it have more time depth than that?
Well, so if we go back at our skeletal elements, let's see. Let's see. There we go. It represents the climate and the distance to the sea through precipitation patterns. So as you could see with the Guadalajara example in my isoscape, the water is dependent on the time that it was collected. So for example, here now during the summer, we have a lot of precipitation. It's the rainy season. So the isotope ratios may vary a bit. So this is something that always needs to be considered. But luckily for me, the values lay very closely to other data collected from Mexico throughout different seasons. So there's actually that actually indicates that there's rather little evaporation occurring overall.
I just had to comment. Michael put a comment there in the chat saying, many thanks. This provides a greatly expanded field of vision, both literally and figuratively. And I definitely have to agree. You were able to bring in some aspects and real world knowledge about where the general person can see and utilize isotopes. So that was great on your part.
Oh.
Next question we have is, with the isotope test, are they also doing a genome test to see what someone might look like?
No. I mean, it's always, unfortunately, with undocumented migrants, it's always a question of cost. So what is currently being done is DNA samples are taken, and the biological profile is established, and we go from there. I mean, you saw the number of undocumented migrants, and the cost of that would just be ginormous. I mean, if you do have funding, go ahead. We all love money. We all want to do our research projects. So feel free to donate to the causes. But as far as I know, it hasn't really been done because, yeah, there are just too many cases out there, and it's too cost sensitive.
All right. Next question is asking, first mentioning, thank you for mentioning migration across the U.S. southern border from central Mexico. I understand this is not your focus, but can you comment, or do you have any knowledge on what is currently known about isoscapes in other places such as Guatemala, Honduras, etc.?
So there has been some recent work by Bartelink and Kramer. She has developed an isoscape for strontium, as far as I know, and that includes the Central American countries, but it was developed on archaeological reference samples. So she went through tons and tons of literature to get these values sorted, and it's obviously going to be very interesting to see how they match up. So I'm going to do that with Mexico, and hopefully we can go from there to move to Central America.
All right. We've got another great comment that came in from Chandra. She's saying, thank you so much for this tremendously informative presentation. You've given us some great ideas for South Africa, where we have a major problem identifying the remains of migrant laborers, saying that they will definitely be in touch with you soon.
Awesome, thank you. I heard about that project, hopefully starting soon, just yesterday. So I'm excited
All
to
right.
get to
Next
talk to you.
question. Do you know where someone can start looking for training in isoscapes?
For training
Training
what?
in
Sorry?
isoscapes?
Ooh, there is the University of Utah. They give summer courses. I think they're called Spatial, and I cannot remember the name of the second course. But they do training in isotopes in general and also isoscapes. And usually I think ArcGIS, so that's what the program is called. They offer some training or consultations as well. But I'm not entirely sure. I pretty much taught myself so far, so I'm probably not the best
We
resource
also
for
have a
that.
couple of comments in the
Yes, Leslie Chesson just comments. Yes. The last comment that was posted in the chat.
All right.
Here we
Next
go.
question is coming from Alex. Was the tap water collection that you did standardized in any way, such as determining if the water was from a local well versus being processed or possibly non-local?
No. So this is one of the difficulties with Mexico. We use tap water and tap water only. Because you really, if you say in Germany, you get into devil's kitchen if you start standardizing that. Mexico is the biggest consumer in bottled water. But from the conversation I've had throughout Mexico, people still use the water to cook, to wash their hair, and do everything else. So yeah, we'll see what kind of effect that has. Two of the individuals that I had sampled at the PCOME matched my model, so that's good news. Hopefully it will continue that way. But yeah, that is definitely something to consider overall.
All right. We had a comment from Ryan Austin saying it would be great to talk to you about your results that he's currently conducting research in Guatemala. So we'll switch back to your final slide that's got your email on it. So
Very
make sure you
interesting.
take that down.
Oh, yes, sorry.
Next question we have that came in was asking what was the equation that was used for the conversion?
Email me and I'll give it to you. That's probably the easiest way because it is a couple of steps that are probably not really interesting to most of us.
Next question is asking, were the bone samples taken from a standard location on the skeleton? I know there's an intraskeletal variation in isotope ratios between different skeletal elements.
I use a rib and a femur. So, and the femur sample was usually taken where the DNA sample was previously taken. So I just moved on from there. So yeah.
Okay. As a follow-up to that, Leslie's asking, are there any published data sets that you know of on intraskeletal isotopic variation? She's only aware of 3 or 4 papers.
I think that's probably 3 or 4 that I'm aware of as well. But I can gladly dig through my millions of papers that I have in my folder and provide you with some if you email me.
All right. Next question is asking, do you have a recommendation as to which skeletal element, either bone or tooth, is more useful in isotope analysis?
It depends on the time period, really, that you want to be analyzing. So teeth are great for analyzing the youth, so birth-ish to young adulthood. And I mean, the bones, depending on which skeletal element you choose, can be the last 5, 20 years. So obviously that depends a bit on the age of the person. If he's not, or he or she is not older than 15, it's obviously not gonna have the variance of the last 20 years. But yeah, it really depends on your research question in that regard.
All right. As you'd mentioned, the border between Mexico and the United States is such a melting pot with so many different origins and nationalities there at one point. Does any of your research spill over into other cultures, and such as Native American or anything along those lines?
Mm, I'm not sure if I know the answer to that question. I don't think so. Um, I guess the person is asking whether persons that are found in the border area may be from Native Americans, since the nations are close to there. Theoretically, I guess that is possible, but usually, yeah, I would think so. No, I hope I
All
answered
right.
that.
Next question is asking, are there any issues with finding the remains in water, such as remains that are in flash floods or bed washes, things like that?
Finding them in general, or the isotope analysis. I guess finding them is not really something that I regularly do. The analysis, as I mentioned before, there can be some issues with water being deposited within bone. But it really depends on how long they were submerged and all sorts of different issues. So it may be feasible to take other reference samples to compare and contrast and whatnot. But teeth, for example, are not influenced, or the enamel at least is not influenced by something like that, by water. So that's good news.
Next question is asking, is isotopic testing applicable to cremated remains?
Oh, Jesus Christ. That is a good question. I have never actually dealt with cremated remains. I have never read of it being done so far. Theoretically, I guess it kind of depends on how badly the person is burned, if it's actually cremated, if there's any skeletal element left that is not completely damaged. I am
Sounds like that
honestly
question
not
might have
entirely
gotten
sure.
your wheels turning just a little bit.
Yeah, definitely. I mean, usually teeth, I guess, are your best bet because they're not quite as damaged.
All right. Next question is asking, will there be any kind of tool for someone to compare an unknown individual to your multi-isoscope isoscape?
That would be cool. I've contemplated with it, but haven't thought about how to do it. I know that if you send your samples to certain companies such as Isoforensics, they do the analysis for you and can also provide you with maps and reference data and all that sort of thing. As far as I know, I haven't worked with them personally, but that's what I know.
All right. For the Dominican Republic victim, what were samples taken? Bones, hair, or teeth? And what isotopes were investigated?
That goes back to let me see. I sampled from the deceased undocumented migrants. I took a tooth, a femur sample, a rib sample, and where applicable, hair sample. And I am doing all the elements. No, I'm doing whatever is possible / whatever is applicable, really. To have a better overview, you're welcome to email me and I can give you my little flow chart.
All right. Next question is coming from Mickey asking, how often did you have to recollect the data?
For the water. So what I did is take 3 samples from each town. So I went to 3 different places within wherever I was at that point. And so then they were analyzed, and luckily for me, the isotopic values have been always very similar within the town. I think that answers it. So 3 per town, and then that is it. There's no going back.
All right. Next question from Tony is asking, is this method currently being used in conjunction with DNA identification with medical examiners throughout the Southwest? If not, do you know of any collaboration that might be in the works?
Well, I mean, the DNA is handled completely independent from the isotope analysis. I know that Professor Bartelink at Chico is working on isotopes of undocumented migrants. There's, I mean, at Texas State, they're trying to collect samples but have nowhere to analyze them because it's very expensive and there's very little funding. But that's pretty much the main issue. I think people would love to have collaborations anywhere, really, and especially the Pima County Office of the Medical Examiner as well, obviously. And but yeah, I think it's just an issue of funding, really.
All right. Next question is asking, are the costs for sampling charged back to the JP, and how does the jurisdiction respond to this?
My research was funded by the AFS and NIJ, so by the research grant that I got. I think that Dr. Bartelink isn't able to charge anywhere yet either. So I think we're still a bit in the kids' shoes here. I mean, so for example, if you send your samples to Isoforensics, obviously they will be able to provide you with a bill. But I'm really doing this for my PhD with my grant money for the purpose of it.
All right. Going back to the different nationalities that are currently crossing the border, if a decedent is found to be other than Mexican, how are they currently categorized if they are Central American?
As in regards to ancestry, or so I mean, isotopically, they can be compared to for example, that archaeological strontium map that Robin Kramer made, or other predictive models. Obviously, that is something that I'm hoping to explore even further. But a lot of the identification efforts also rely on circumstantial evidence. So if a person has currency from Guatemala, then he probably was coming initially from somewhere south of Mexico. So yeah, I think that should answer it.
All right. Going back to the water sampling and collection question, Vicky was also wondering if these will need to be updated in the future or if they are reliable for long-term use.
Obviously, always a good idea. It would be interesting to sample during the winter months just to see how the drought is going to influence everything. But again, as I said earlier, from comparing my data to data that has been previously collected throughout the year in the 2 GNIP collection sites in Mexico, there was little evaporation, so that's good news. But I mentioned it a couple of times by now, an isoscape is really only as good as its reference, and more reference samples obviously would make a better isoscape. So if you're ever traveling around Mexico or Central America or South America, find yourself a research institute that wants to analyze your water samples, and then we will get even better isoscapes.
All right. We did have a couple of comments that came in. One was from Vanessa saying that, yes, collaborations such as that are in the works, such as from CSU and Chico. So that's good news to hear.
Yes, Dr. Bartling, Professor Bartling.
And then
the one that I mentioned. Yeah.
Leslie also mentioned
That's what I
that
thought.
most studies have suggested that teeth are more resistant to diagenesis than bone, but bone also
To
provides a different
diagenesis. Yeah.
snapshot of time. Do you have any follow-up on that?
Yeah. Yeah. I don't think so. Yep. That's, I hope what I said earlier. I hope I didn't get anything mixed up. Yeah. It should, that should match what I said, I
Well, I
think.
think that's all the questions that we've had come in for today. So we are going to go ahead and move into our closing, but before we do, I would like to just give you one last thought to leave our audience with. Do you have anything that you would like to just say to our audience before we do go into our closing?
Well, thank you so much for listening, and I'm excited to get talking to you all, and yeah, hopefully I will get a lot of
Thank you
emails
so much,
about this.
Saskia. As
Thank
we
you for
mentioned,
listening.
make sure to look down there in the bottom of your screen. You will see Saskia's email address in case you do have follow-up questions or would like to reach out to her directly, so be sure you take that down. Also in the bottom left-hand corner of your screen, you will see our file share pod that does have a downloadable PDF version of today's slide deck. So please feel free to go ahead and click on the name of that file and then click the download file button directly below that to download that PDF version before you leave today. As always, we do want to thank our subject matter expert, Saskia Amir, for her presentation, as well as all of the research that she has done. It seems it has been very vast, and we appreciate all the time and effort that she has put into it, as well as taking time away from her day to present today. We also want to thank our attendees for joining us. These webinars are just simply not possible without your attendance and your support. So as we always ask before you leave today's webinar, we do ask that you participate in our short survey. You'll find it there in the middle of your screen. Simply click the word here, and that will open up a new window for you. If you could run through that quickly before you leave, your feedback about our webinars is always vital information that we try to use to provide you with the best webinar experience, as well as to adjust any content as well as the way that we disseminate that content out to your audience. So please take a few moments to complete that before you leave today. You will see there in the chat pod, we have Julian posting some of our social media outlets such as Facebook, LinkedIn, and Twitter. So be sure to follow us on all of our social media outlets if you are not already. You will also see there our podcast. We just started a new season of our podcast this week. So be sure to subscribe to that to be up to date on all of our podcasts. And then you will see our website there where you can find all of our no-cost webinar and research offerings that we offer weekly. And we will be having more webinars coming up next week, so be sure to check those out as well. Again, thank you, Saskia, for your presentation. Thank you, everyone, for joining us today, and we hope everyone has a great afternoon.